NASA's tests found a second Earth-sized world in the habitable zone of the TOI 700 system. This planet, called TOI 700e, is likely rocky and orbits closer to the star than its sibling TOI 700d, another Earth-sized planet. Planet E orbits within the star's optimistic habitable zone. These are distances from the star where liquid water could exist under the right conditions. Planet D is in the conservative zone, where it is more likely that both an Earth-like atmosphere and liquid water could exist.
This marks the most recent Earth-like planet identified by NASA amid a multitude of other exoplanets. It took us a considerable amount of time to comprehend the existence of other galaxies and recognize the twinkling lights in the sky as distant suns, each potentially accompanied by orbiting worlds that could harbor alien life. Initially, we were unaware of any planets beyond our solar system due to our limited detection capabilities. In the early 1990s, a turning point occurred as we began successfully detecting planets. With missions like the Kepler telescope actively scanning the cosmos, we have identified well over 3,000 planets. Consequently, it's now conceivable that nearly every star in the night sky is accompanied by planets, an astonishing realization. As you gaze at the stars on a clear night, it becomes apparent that solar systems are ubiquitous. This leads us to contemplate the number of potentially Earth-like planets within the Milky Way galaxy, and the estimate is staggering. About 20 billion. By Earth-like, we mean a rocky planet positioned at the right distance from its star, creating conditions conducive to liquid water on the surface. Roughly 1 in 10 stars falls within this habitable zone. In our own solar system, 3 planets, Venus, Mars, and Earth, are situated in the habitable zone. While Venus is close to the Sun and Mars is farther away, both planets, like Earth, are believed to have had water on their surfaces, rendering them potentially habitable. Even today, we continue the search for signs of life on Mars. Discovering life on Mars would unquestionably rank among the most significant achievements in human history. However, if life does exist on Mars, scientists believe it's likely to be microbial. The more intriguing prospect, the kind that could revolutionize our understanding of the universe, involves the discovery of multicellular life, such as plants or animals. Fortunately, within our solar system, there's a potential host for such life. Preparing for the Europa Clipper mission, NASA aims to explore Jupiter's moon, Europa. The mission, scheduled for launch in October 2024 and arrival in 2030, is designed for a 4-year scientific investigation of Europa, a moon that strongly indicates the presence of a liquid water ocean beneath its icy surface. The primary goal is to uncover evidence of extraterrestrial life beyond our solar system. Current technology makes sending space probes to find such evidence extremely challenging, if not impossible, due to the vast distance to the nearest star, Proxima Centauri, located about 4.2 light-years away from our Sun. Instead of relying on space probes, the strategy involves patiently monitoring radio signals and directing telescopes toward exoplanets to search for biosignatures, potentially revealing signs of life in the universe. At the top of the hierarchy of alien life excitement is the prospect of intelligence. Predictions estimate that given our current pace of technological growth, a civilization could colonize the entire galaxy within 10 million years. Enrico Fermi, a renowned Italian physicist, posed a simple yet profound question known as the Fermi Paradox. Where is everyone? With countless planets in our galaxy and ample time for complex life to emerge, one would expect several civilizations to have become spacefaring. The conundrum lies in the apparent contradiction between the history of life on Earth, which suggests a lengthy and unlikely process, and the vast cosmic real estate available. Consider our trajectory as a civilization. We are rapidly advancing towards becoming a spacefaring society. In 1,000 years, if we avoid self-destruction, we could inhabit Mars and the Moon, taking our initial steps toward the stars. Extrapolating further, in 1,000,000 years, we should evolve into a full-fledged spacefaring civilization. Now, think about the age of the universe, 12 to 13 billion years. Even if a few civilizations preceded us by 1,000,000 or 1,000,000,000 years, it's negligible in the cosmic timescale. The paradox deepens. If these advanced civilizations exist, why haven't we detected them? Some suggest that perhaps there is a finite lifespan for civilizations, leading to self-destruction or a failure to achieve spacefaring status. This raises the possibility that becoming a spacefaring society is not an inevitable outcome for intelligent beings. The Fermi Paradox suggests that there might be a significant obstacle in the progression of life, from its early stages to reaching advanced levels on the Kardashev scale. This hurdle could explain why we haven't detected extraterrestrial life yet. One possible explanation is the idea of a great filter, a barrier that makes the emergence of intelligent life exceedingly rare, possibly due to self-destruction. To explore this further, we can look at the evolution of telescopes capable of detecting technosignatures. If many planets exhibit these signatures, it could indicate that the great filter is behind us. Conversely, a lack of technosignatures on planets with life might suggest that the great filter lies in the future. Another intriguing resolution to the Fermi Paradox suggests that advanced extraterrestrial species might transition from traditional biological forms to machine intelligence. In this scenario, a fully digital civilization may have no interest in colonizing the galaxy, which could explain why we haven't encountered them. UFO enthusiasts propose the zoo hypothesis as another solution. This theory speculates that we are being observed without our knowledge, similar to a cosmic zoo. On a more pessimistic note, the Fermi Paradox could be resolved if we are the first intelligent civilization in our galaxy and face extinction long before others emerge. Ever wondered about the possibility of life beyond Earth? Astronomers suggest that there might be around 20 billion potentially Earth-like planets in our galaxy. It's an estimate, not a certainty, as we haven't discovered life elsewhere yet. But here's an intriguing thought. On Earth, life emerged almost as soon as conditions allowed, around 3.8 billion years ago. Picture this. As soon as the Earth formed and oceans appeared, signs of life followed. Now this might make you wonder, could the origin of life on a planet be highly probable under the right conditions? It's a fascinating concept, considering what we observe right here on our own planet. But let's dive deeper. Complex life, not just single-celled organisms, started showing up on Earth about 600 million years ago. That's within the last billion years of Earth's history. Think about it. For the first 3 billion years after life originated, there wasn't much happening in terms of complex life forms. It was a slim period of activity. Now here's a captivating question. Why did it take around a third of the age of the universe on Earth to go from the origin of life to beings capable of thought? The conditions needed time to align. A stable star, sufficient fuel, and a planet with a secure orbit, free from too many asteroid collisions. Imagine the journey from the dawn of life to the intricate beings capable of thought. A journey spanning billions of years. Picture the eukaryotic cell, the building block of complex life on Earth, the very foundation of what we are. But how did this complexity arise? Picture a bacterial cell, a primitive entity, finding its way into another cell, an archaea. Rather than meeting its demise, it thrived and multiplied. This, it seems, is the origin story of all complex life on our planet. One might ask, what were the specific events that led to our existence? As we delve into these intricacies, it becomes apparent that Earth might be a truly unique place. The evolution of life, the merging of cells, the delicate balance that allowed for the existence of plants, insects, and us. It's a series of improbable events. Consider this. Could Earth be the sole abode of conscious thought in our galaxy? Is our blue planet the only one where meaning exists among the vastness of 400 billion stars? Reflect on the significance of such a possibility. Now let's ponder the implications. If we, the inhabitants of this singular celestial body, were to make a grave decision, pressing the button that unleashes nuclear war, we might extinguish not only ourselves, but also the only known haven of meaningful existence in our galaxy. In this grand cosmic theater, are we the only actors with the ability to contemplate our own existence? The fragility of our position in the vastness of space raises thought-provoking questions. What if we hold the exclusive privilege of being the thinkers in a galaxy of stars? The responsibility becomes weighty, for our actions could impact the very essence of meaning beyond our planetary borders. Have you ever seen a UFO or alien in real? Well, here's a video of one that was found in New Mexico. Let us know your thoughts in the comments section down below. Don't forget to hit the subscribe button and press the bell icon so you never miss out on upcoming videos. See you all in the next one.